All right, today we're going to tackle one of the boldest ideas in modern physics. I'm talking about a theory that tries to build our entire super complex universe from something, well, incredibly simple. So, for just a second, I want you to forget everything you know about the particle zoo. All the quarks and leptons. Forget tangled strings, forget extra dimensions. Just ask this one question. What if the entire universe is actually simpler than we think? What if everything we see, from quarks all the way up to galaxies, from the speed of light to the force of gravity, what if all of it just emerges from something way, way simpler at the bottom? Well, that's the core idea behind something called the Unified Compression-Based Field Theory, or UCBF for short. And get this, it proposes that underneath everything, all of reality is built from just one single type of particle. And it's all governed by just four simple rules. That's it. That's the entire toolkit you need to build a universe. Okay, so let's think about this. If you're going to build a universe from scratch, what's the very first ingredient you need? Well, this theory starts with the most fundamental building block you can possibly imagine. They call it a voxel. And honestly, the best way to think about it is like the ultimate pixel of reality. You know how your screen is made of tiny pixels? The idea here is that reality itself is made of these voxels. Now, the paper gets a bit more technical, defining it as a point-like spin-zero boson. But the key takeaway is this. In this model, everything, and I mean everything, is at its deepest level just a giant collection of these identical little points. But, having just a single building block isn't enough, right? You need rules. You need an instruction manual for how these voxels are supposed to behave. And the UCBF theory, it only proposes four of them. Just four. And these rules are, frankly, incredibly basic. Rule number one, the voxels exist. Okay, simple enough. Rule two, they have to interact with each other in a special way that stops them from just collapsing into a black hole. A bit of personal space. Rule three, just like pretty much everything else in nature, this whole system of voxels is always going to try to settle into its most stable, lowest energy state. It wants to get comfortable. And finally, rule four, there's a single, fixed energy scale. You can think of it as setting the volume for how strongly they all interact. So there you have it. One particle, four rules. The question is, what happens when you press play? What kind of universe actually emerges from a starting point that's this simple? Well, the answer is surprisingly orderly. And here's what's so cool about this. The theory doesn't just pick a structure out of thin air. It actually calculates it. Given those four rules we just talked about, the voxels naturally arrange themselves into this beautiful crystal-like structure. It's called a face-centered cubic lattice, or FCC for short. And why that one? Because it's the most stable, most energy-efficient way for them to pack together. So in this model, the universe, it's basically a giant quantum crystal, a supersolid. And this idea, it shows you the deep logic of the theory. It's a chain reaction. First, you get the fixed geometry of this cosmic crystal. That geometry creates coherence, basically a predictable relationship between any 2 points in space. And that coherence is what gives rise to causality, the whole idea that a cause has to come before its effect. So the very structure of space itself dictates how time and interactions work. It's really profound. Okay, conceptually, this is all fascinating stuff. But now we get to the part where the theory makes its most mind-blowing claims. This is the real payoff, right? This is where this simple little model turns into an incredibly powerful predictive engine. You see, most big theories of everything are loaded with what we call free parameters. They're like these little dials you have to tweak and tune just right to make the theory match the real world. But the UCBF model, it's totally different. To set the scale for its entire universe, it only needs one single number, one measurement from the outside world. And that one number? It's the Rydberg constant. Now, this isn't some obscure value. It's one of the most precisely measured constants in all of science. It has to do with the light that atoms give off. In this theory, you take that super precise number and you use it to anchor the entire model. It sets the physical distance between the voxels in the lattice. So, here's the crucial point, right? Once you plug in that one number, the Rydberg constant, everything else, everything, should just pop out of the theory's internal logic and its geometry. No more dials to tune. So, what does it predict? Let's take a look. First up, the speed of light, c. In this model, c isn't just some abstract cosmic speed limit someone made up. No, it's the actual top speed a wave can travel through this voxel crystal.
Think of it like the speed of sound traveling through a diamond. It's a direct result of the crystal's stiffness and density. The key thing here is it's not assumed, it's calculated.
Okay, next on the list, Planck's constant, the absolute cornerstone of quantum mechanics. And again, same story. It's not a given. It's an emergent property. It's derived from how the voxel's mass, the spacing of the lattice, the speed of light we just calculated, and the coherence of the whole structure all play together.
And then there's the fine structure constant, alpha. This number, it's about 1 over 137, and it has driven physicists crazy for decades. Why that number? Why is it what it is? Well, this theory claims the answer lies purely in the geometry and the topology of that FCC crystal. The calculation gets deep into the weeds, with things like flux counts and defects in the lattice, but it all comes from the structure itself. It's a pure number that just emerges from pure geometry. It's wow. But wait, it doesn't even stop with the constants of nature. The theory goes another step. It says that the fundamental particles we know and love, electrons, quarks, all of them, are really just specific kinds of defects or vibrations in the voxel crystal. Think of them like little knots or specific sound waves echoing through the lattice. And if that's true, then the theory should be able to calculate their masses too. And just look at these numbers. Seriously. On the left side of this table, you've got the masses predicted by the theory, again, calculated purely from its internal geometry. And on the right, the actual values we've measured in our giant particle accelerators. We're talking about the electron, the up and down quarks, the W boson, even the Higgs boson. The predicted values they're just astonishingly, breathtakingly close to what we actually observe. I mean, the numbers are absolutely compelling. The internal logic is beautiful, it's elegant. But this brings us to the biggest question of them all, doesn't it? What are we really looking at here? Is this theory describing actual reality? Well, the author of the paper, Corey Brent, is actually really clear on this point. He explicitly says that this is a representational unification model, not a metaphysical claim about ultimate reality. What does that mean? It means that even if the theory is perfectly successful, it only proves that our known physics can be represented as emerging from the simple crystal structure. It doesn't necessarily mean that reality is a crystal structure. It's the classic idea. This could be an incredibly accurate map, but it's not the territory itself. And that really leaves us with the ultimate question, doesn't it? Is a theory like this, one that starts from almost nothing and manages to derive almost everything, is it giving us a genuine peek behind the curtain? A glimpse at the true fundamental structure of existence? Or is it the ultimate testament to human ingenuity, the most elegant, self-consistent mathematical map of our universe ever created? For now, the answer's still out there, just waiting to be tested.